Hi, math students, it's Miss Carol again, and we are back for lesson 23 for project 5. And we have 4 questions that are still dealing with the obstacle course. All right. And in this section, we're going to get a little bit more complicated, but it's really not too bad. We're going to be dealing now with rotations instead of reflections. So Helena stopped at checkpoint C, which has the coordinates -4 and 5. And then she gets to checkpoint D at -3 and 2 by crawling underneath barbed wire. She will have to crawl underneath barbed wire between the next 2 checkpoints E and F as well. What are the coordinates of checkpoints E and F if line segment EF is located at line segment CD's location in a 180 degree rotation of the course? So I have over here gone ahead and put CD on our grid, and I am going to imagine rotating this entire line segment 180 degrees. And right now, since we're in the the second quadrant, I know that the 180 degree rotation from the second quadrant is going to be my fourth quadrant, okay? So if point D is at -3 and +2, then I know that my 100 degrees or 180 degrees opposite that, okay, is going to be at +3 and -2. Okay, so that's 180 degrees difference. All right, and you can see that they're going to lie on this straight line here. So, and then my 180 degrees difference for point C, if point C is at -4 and +5, then our point E will be at +4 and -5. Okay, so this would be EF. All right, so that's my rotation, 180 degrees. All right, and one thing to think about, a straight line is 180 degrees. So if I have a point here at -3, 180 degrees difference will be here. If I have a point here at +2, 180 degrees difference will be at -2. So that's why this works in the coordinate system. I can say, okay, I'm exactly opposite. I have -3 and +2. Now I'm going to have +3 and -2. Okay, hopefully that seems to make a little bit more sense to me. Hopefully it does to you too. Okay. So again, my points are at +4 and -5 and +3 and -2. Make sure you get those right because there's a lot of positives and negatives floating out there. Okay, question 2. What is the relationship between the length of CD and the length of EF? Okay, well, if it's simply a rotation, we're not, and we took CD and we rotated it, we're not changing the length of that line at all. So they are exactly the same length. All right. Question 3. Let's look at this graph. When I first did this question, it took me forever because I didn't read it right. So let's make sure we read it right. So if I take EF, which is right here, and I rotate it 90 degrees clockwise, I will get to E prime F prime, okay? How could I produce the same image by rotating CD? All right, well, if I rotate CD 180 degrees, okay, I'll get here. So remember, I have -3, +2, +3, -2. This looks like -4, +5, and then this would be +5, 5, or excuse me, positive 4, negative 5. All right, so I know that EF is a 180 degree rotation from CD, and I also know that E prime F prime is a 90 degree rotation from EF. So I am going to take my 180, that was really easy to figure out, okay, because my coordinates were just opposite, and then add what I was already told was 90 degrees, and I get 270 degrees. When I first looked at this, I thought it was a counterclockwise rotation, and that's not the case. They're actually going here and then here, so it's a 270 degree clockwise rotation. All right, so all you need to do here is just type 270 into that box. And that's it. They already have the little degree symbol and everything in there for you. Okay, question 4. Describe another series of transformations, not including a rotation, that maps CD to EF. Okay, so I think what we've already kind of discussed in previous lessons is that we could first do a reflection on the y-axis, okay, and that would put us here, okay, so a reflection on the y-axis would put us here, and then a reflection on the x-axis would put us here. So let's go ahead, type in a to get from CD to EF, we could also perform a reflection on the y-axis followed by a reflection on the x-axis. Okay, we could also go x-axis then y-axis. Either way, we're getting two reflections over axes. Okay, so that's a 90 degree, it's the same as a 90 degree rotation, and followed by another 90 degree rotation is the same as a 180 degree rotation. So I guess what they're trying to show here, and it's important, is that there's more than one way to kind of move objects around a coordinate plane. We can rotate, we can reflect, and we can translate. So there's a lot of different ways to move objects around, and they really want you to be comfortable with the visual aspects of all that. So hopefully that helped. Thank you for joining me, and I'll see you back here for lesson 24.